Okay, so now to finish up 7.3, we've got some quadratics. And remember when we were talking about the notes, you could think of that as 2u squared minus square root of 3u equals 0, where u is cosine theta. The u is always the middle term. So if you want to think of it that way, you can. I don't know, whatever you want to do. So if I have something like this, 2u squared minus square root of 3u equals 0, I say, what's in common to both? It's u. U is the common factor. Where were you? Well, you were at 0, which means cosine theta is 0, and 2u minus square root of 3 was 0. 2u is square root of 3 because you're adding, and then u is at square root of 3 over 2. So that was cosine with square root of 3 over 2. Now, what does that mean? That means, are there any places where it's 0 comma something? And are there any places where it's square root of 3 over 2 comma something? Well, let's see. On the unit circle, the first place is at pi halves. Because we look going around here. Oh, we found another one. That's at 3 pi halves. And then where is it square root of 3 over 2? Right there at pi 6, and then all the way around to 11 pi 6. So this was really, whoops, I wrote that wrong, my bad. I know what I meant, but I didn't write it right. This was at pi halves, it's 0, 1, and at 3 pi halves, this is 0, negative 1. My bad. So then these are your answers. So in this case, we want where is it a half and where is it negative a half? Well, that happened up here at pi 6 and down here at 11 pi 6. I don't know if you want the equal sign or not, but 1, 2, 3, 4 answers. 1, 2, 3, 4 answers. Now, these were not all the same denominator of 6 like we had earlier, because whenever you have either sine or cosine 0, it's probably going to be different. Okay. So here we're doing some weird stuff. We have tan theta minus 1 times cosine theta plus 1. That is kind of weird. But when you think of like what they call the zero product property, it's not that bad. So we would basically just say tan theta minus 1 equals 0. So tan theta is 1. And then we'd also say cosine theta plus 1 equals 0. Cosine theta is negative 1. Now, this one is actually easier than that one. This means on the unit circle, where is x equal negative 1? X is negative 1 there at pi, because it's negative 1, 0. So pi is an answer. But then where is tangent equal to 1? It's where you have square root of 2 over 2 for both, and where it's negative square root of 2 over 2 for both. Because if you're dividing y divided by x, remember tan is y divided by x, then they have to be identical. The same sign on both. Since it's equal to 1. If it were where it said tan theta plus 1, for example, because you know how Math Excel is, then this would make it tan theta is negative 1. And so one of these would have to be positive and the other negative. So what we want is pi force where both are positive and 5 pi force where both are negative. Now again, if you had that plus, then you need this one, which is 3 pi force, and this one, which is 7 pi force. But here we go, pi force. I guess I'll put equal. And this one is down here. Remember, every single trig function is negative in this quadrant except for tan and cotan. That's quadrant 3. So that's 5 pi force. So that's how I'd recommend doing that. Because otherwise you could graph it and you wouldn't get exact answers. You know, what do you do? Okay, so here we go with cosine theta equal sine negative theta. If I were you, I'd probably just use your even odd property. So sine negative 1 or sine negative x is negative sine x. Okay, so what does that mean? That means that cosine theta equal negative sine theta. So where is cosine the same thing as the opposite sign of sine? So again, where is cosine the same as sine? Whoops. Except for a sign change. So in other words, where is one of them square root of 2 over 2 and the other a negative square root of 2 over 2? Or vice versa. So where is cosine the same as sine except for a little sign change? Well, that'd be where one of them square root of 2 over 2, negative square root of 2 over 2, and the other would be negative square root of 2 over 2, positive square root of 2 over 2. So I know this is a little unusual, but that's what it means. I'm really trying to get you to understand it. So this is where one of them's positive, the other's negative. Well, that's here at 7 pi force. And this one is at 3 pi force. Is there another way to do it? Yeah, there is. So the other way is say cosine theta is negative sine theta. Remember that tangent is sine over cosine. And so that means we would want sine on top. It's y over x. So if we want sine on top, we'd have to divide by cosine. So cosine divided by cosine is 1. It's not 0. Dividing by the same thing as 1. So 1 equal negative tan theta. And so I want to reverse it. Negative tan theta equal 1. Well, that means tan theta is negative 1. Well, where does that happen? At these two spots we already talked about. At 3 pi fourths and at 7 pi fourths. So you can do your thought process where they're the same except for a negative, or you could do the math where you change it to tangent and you get the same answer. There you go. Okay, here on this one, we have tan theta is negative square root of 2 sine theta. That looks a little weird. Well, we do want to remember that tan is sine over cosine. Well, what if we change the problem to sine theta over cosine theta equal negative square root of 2 sine theta? See if this helps. If we multiply both by cosine, we get sine theta equal negative square root of 2 sine theta cosine theta. And then we would divide by sine. So you get 1 equal negative square root of 2 cosine theta. So then divide by negative square root of 2. Remember when we rationalize that, that's negative square root of 2 over 2 from doing square root of 2 on top and bottom, multiplying straight across. Okay, so again, we're back to where is x equal negative square root of 2 over 2. It's right there at 3 pi fourths and right there at 5 pi fourths. Right there and right there. And that's 2 of your answers. Why are there more than 2 answers? I thought we divided it out. Well, you got to be careful. So we got our 2 answers, but we need to figure out why is there 4. Well, watch out for any divide by 0 situation. So where was sine theta equal to 0? So that means where is y equal to 0? Over here at 0 and over here at pi. And those are your answers. So it's the same idea as if you're doing, if you had something like 2x equal x squared and you divide by x, you have 2 equal x, but then also x cannot be 0. It's that same idea where you got to watch out for divide by 0. So that's what you got to do. Now, this would probably be a good one to double check through the graph. How many answers am I supposed to get? Function 1 is tan x. Function 2 is negative square root of 2 sine x. How many answers am I supposed to get? So if I go to the document, tan x, and for f2 I get negative square root of 2, go to the right, and then sine x. I got a bunch. Now I just want from 0 to 2 pi. So like before, we go to the window settings, 0 to 2 pi. 1, 2, 3, 4. Let's just double check them. Intersect. Now when it says lower bound, it means left. In this case, I can't really do it because it's 0. But here's another one. So my answers were 0, 2.356. Where else? Again, I don't care about the y answers, I care about the x answers. Oh, there's one at pi, 3.14. There's 3.927. Okay, well, what was 3 pi fourths? Was that one? 0 is that one, pi is that one. What is 3.297? 5 pi over 4. So again, combination of methods if you want to double check. I think the most common mistake from when I've taught this before is, oh, I got 2 of the answers, there's supposed to be 4. So remember on that problem, check if 2, 3, or 4 answers from the graph. Okay, but it's all because of this divide by 0. So take it for what it is. If we were dividing both sides by cosine, we'd want where cosine was 0, which would have been at pi halves and 3 pi halves. So take it for what it is. Okay, now on this one, we have 2 plus 2 sine theta equal 4 cosine squared theta. Well, remember out to the side we have our Pythagorean identity. Sine squared plus cosine squared is 1. Not theorem. Pythagorean identity. Well, that meant that if I have cosine squared, that's 1 minus sine squared. Okay. So I could call this 2 plus 2 sine theta equal 4 parentheses 1 minus sine squared theta. That's just a straight substitution. Now, it would be harder if you had to do the one with secant or tangent, because you're probably not as used to that. But it is exactly what we talked about on day 1 of the notes. You know, your 3 Pythagorean identities really turn into 9. There's the cosine squared is 1 minus sine squared. Okay, so that's your first step. Second step would be multiply your 4. 4 times 1 is 4. 4 times negative sine is negative 4 sine. So negative 4 squared theta. Now, what we want is a positive, the sine squared theta term positive. And so we're going to move everything to the left. So we have 4 sine squared theta plus 2 plus 2 sine theta equal to 4. If you didn't need to take this extra step, you don't have to. You could have said 4 sine squared theta plus 2 sine theta minus 4 equals 0. Or you could have skipped ahead if you're fast. 4 sine squared theta plus 2 sine theta, then 2 minus 4 is negative 2. Speed doesn't really matter to me on this problem. I just want you to understand it. Now what we want to do is if every term is even, you're going to want to factor out your GCF, which is 2. So that's factoring out the GCF. 2 times 2 sine squared is 4 sine squared. 2 times sine theta is 2 sine theta. 2 times negative 1 is negative 2. Now we divide by 2. So you have 2 sine squared theta plus sine theta minus 1 equal to 0. So can we factor that? I don't know. Can we factor it? I don't know. Well, our middle term has to be positive. So what if we had a plus 1 here and minus 1 here? Let's check it. 2 sine times sine is 2 sine squared. 2 sine theta minus sine theta is sine theta. Negative 1 times 1 is negative 1. So yes, we could factor it. If you don't like doing it that way, you could have said 2u squared plus u minus 1 and then factored it. At any rate, we have 2 sine theta minus 1 equals 0. So sine theta, you move it to the right, so it's a positive 1. You divide by 2, so it's a half. And then this other one, sine theta plus 1 equals 0, so sine theta is negative 1. Where are the two places where y equal a half? Go back to your unit circle, and it's at pi 6 and at 5 pi 6. Where is y equal to negative 1? Does it happen twice or once? Only happens once at 3 pi halves. That's why there are 3 answers, not 4. So if you're looking at your unit circle and it says, well, this is negative 1, well, that only happens one time on this whole big circle. If it's about this one, negative 1 for cosine, it only happens once on this whole big circle. But if you wanted a y value of 0, you got 2 spots. If you wanted an x value of 0, that's 2 spots. That's why sometimes there's 3 answers and sometimes there's 4. Okay, now for our last one. Cosine squared minus sine theta equal 4. Since your answers are in line, you can already see the answer. Well, let's graph it so we can get used to it. Start your parentheses, press cosine x squared. And then minus sine x. Okay. Looks like a tooth, or several teeth. Or it could be like a mountain range. Okay. And then F2 is 4. Well, that doesn't cross at all. No solution. Doesn't cross. Looks like teeth. Or a mountain range. LOL. If it does not cross, there's no solution. If it did cross, you'd have to do the intersection and get it. All right, hope all those help. Have a good day.